would be kind of hard to do in R, all the pairwise analysis. So how do you implement good audio in Unity? The rough idea, and we'll see a demo in a second, but the rough idea is you enable the plugin or you import it. You tell the engine that it should use that plugin, like SteamAudio, Oculus Audio, or anything like that. You attach this geometry and material script to things that will occlude or bounce off rays of sound or whatever. You attach a listener component to your camera. You attach the SteamAudio component or Oculus Audio component to your audio sources. In Unity, by default, it uses 2D sound, which means that you can't tell where something is located. We'll see this little slider that lets you move it to 3D sound. There will be this thing that's like a SteamAudio Manager or something like that that you use to generate some mesh, which is it's just some pre-computed static mesh that the systems use to bounce rays off of. We'll see it in a second. There's this button that'll be like export the scene, and then you can play and it will work. So let's show you how to do it. I'll do it in Unity first. Let me close this. Don't save. So let me make a new scene. So, okay. All right, it's not deleting that thing that I wanted to delete. It has full control. All right, well, I give up. Anyway, if you make an empty scene, you'll just have a camera and a light, basically. You won't have the SteamAudio settings, but you can ignore that for now. What I'm going to do is quickly make a floor for me to run around on. I'll just make a plane, zero it out. In this example, I am using first-person character, but this will all work with your VR character as well. So I have this. Also, stop me if I'm going too fast. I have some first-person character. I'll remove some things like camera shake, which is kind of annoying, head bobbing. That's about it. And so, whenever you feel like doing it in Unity, I can walk around. That's pretty basic. I'll make the plane a little bit bigger so that I don't fall off of it. Okay, so in Unity or Unreal, you can add an audio source by just creating an actor or game object and then attaching an audio source component to it. So for example, in Unity, I want to be able to see it, so I'll make a sphere somewhere. So this will be my audio source. I can add an audio source component to it. And it will have some parameters like the clip and so on. I imported this song called Jungle. And that's all you really need to do to just get any kind of sound working. You'll notice some limitations in a second. So it doesn't change based on where I'm looking because by default it's not spatialized. You can hit this spatial blend thing. You can make it 3D to make it be spatial. By default it's 2D, so it's essentially just an ambient source by default. Makes sense? So this spatial blend should be 3D so that it actually sounds 3D. But the limitation of pretty much all of these audio systems is that they don't do any kind of reverb or occlusion by default. So, okay, that's an email. If I throw a wall into my scene, it's a pretty good wall. Move my character way back here. Put a wall right here. The light source, I'll make like this. That's pretty ugly, but you know, whatever. Yeah, it looks amazing. Anyway, I threw a wall into the scene and the wall doesn't actually block the sound or anything. So if I go behind the wall, the sound source still sounds the same. Can you hear it? Is it too low? Like, it's not actually like pointing in my direction, so it's hard to tell if it's too loud. I'll make it slightly higher. Anyway, the wall doesn't block any sounds by default, so we can add occlusion. In this case, for assignment 8, I'd recommend SteamAudio because I think it's easier to work with. You can download any of these audio APIs by just saying like SteamAudio, going to the website and downloading the relevant version. So for SteamAudio, for example, you can download the Unity package. I've already downloaded it. It will show up like somewhere. I don't know where I extracted it. Desktop maybe? I don't know, somewhere. Let's see. Okay. I don't know where I extracted it, but I know that Unity will find it. So if you go to Assets, Import Package, you can import it. So it'll look like a little Unity logo and it'll say Unity Package. And you can import it that way. And that'll import all of the audio APIs. Anyway, I've already done that and it created a SteamAudio library for me, a SteamAudio folder. And to enable SteamAudio inside of Project Settings Audio, I can kind of just enable it that way. It has a spatializer plugin option. By default, it's none. You can change it to SteamAudio. There's an option for ambisonics, which I'm not using right now. Ambisonic sound is basically fully 3D sound. So by default, you kind of just have stereo sounds. Your music sounds like it's coming from the left or the right. Ambisonic sound is like it can come from anywhere. So it sounds like full surround sound almost. If you were like in the center of a sphere of speakers, that's what ambisonic sound would be. Anyway, so you can enable SteamAudio this way, and if you go to Window SteamAudio, it won't delete mine, but for you it will create this thing called SteamAudio Manager, and from here you can do a lot of things. I just threw it down here so that I can always look at it. But yeah, that's just importing the plugin. Is anybody lost? All good? Okay, yes?
I'm curious, does SteamAudio have ambisonic sound like by default? Like could you set SteamAudio to be the ambisonic sound?
Yeah, I can. I'm just not for now. But yeah, it has ambisonic sound. It's just, I don't remember exactly, but I think the file format is slightly different or something like that.
Okay.
It just has to be handled differently. Because by default, your character is just like a thing with 2 ears. So they just assume it's stereo, or binaural is a more accurate term. It just means that you have 2 audio listeners, essentially. So now we can add the scripts that I said we should add. So we can tell Unity, or tell SteamAudio that the camera is a listener. So there's a SteamAudio listener component. I will tell it that my wall, well, I'll tell it first that the audio source itself is an audio source. Source, SteamAudio source. It will have some options that we'll play around with in a second. And I also tell it that these things, the wall and the plane, let me just assume for now that only the wall will affect sound, just for example. To the wall, I will add, it'll change, it's just an obstacle component. SteamAudio calls it geometry. I think Oculus Audio might call it something different. But this geometry gives you information about its shape so that it can use it to bounce rays off of it and other things. And I can also add a material to it, SteamAudio material. So here I just did basically exactly what my slide said we should do. Is anybody lost so far? Cool. For all of these APIs, to make it do anything, you need to keep clicking export scene every time you make a major change. Export scene is just a thing for the internal audio library to know where the geometry is and things like that. So by default, your audio source has information about occlusion, reflections, and so on. By default, I'm just going to enable occlusion. I'll turn HRTF interpolation to bilinear, which is just slightly more accurate, I think. I'm going to change the direct sound occlusion to be on no transmission. Does anybody know what no transmission means? No transmission means that it's not possible for the audio to go through that object. So I shouldn't hear any audio at all when I'm on the other side of the wall. So I'll hit my pre-export scene button. I'm going to set the simulation preset to high so that it hopefully sounds good. And oh man. Do I need to change parameters? Generic, brick. Let's see. Oh, when you enable SteamAudio, audio sources have the spatialize option that you also need to check, I believe, to get anything to work. It's this hidden option that just shows up. If you look at the SteamAudio tutorial, you can also see stuff like that. I can't hear it. Damn. So no transmission. There's no muffling at all. It just cuts off. And there's no diffraction, which you can tell because in the real world, if I'm at the very edge of the corner like this, I should still be able to hear the sound. But in this case, I can't. So there's no diffraction being modeled. So let's say that I want to model the muffling inside of the SteamAudio settings. Oh, by the way, in the 3D sound settings in Unity, you can change this logarithmic function, which says like how far you need to be for it to sound like a certain volume. I'm going to make it relatively short just so that the effect of the spatialization is more obvious. So your listener is at this part of the graph right now. Make sense? Is anybody lost? Pre-export my scene. Anyway, well, I'll show you what the effect of that is. What that means is that here it'll be really quiet, and when I get close, it'll be really loud. So that's what a logarithmic function does. It just makes it really loud when you're right next to it. Anyway, let me muffle my wall. So the muffling would be done by having occlusion, but with transmission. Does anybody have a guess for what frequency-dependent transmission is versus independent? Yes?
I think if it's dependent, then it'll change based on the frequency of the sound. So if, like, you can block the low frequency stuff, something like that. One of those.
Yeah, that's more or less how it works. So frequency-dependent transmission would muffle higher-pitched sounds harder than low-pitched sounds. Like the difference before and after would be a lot more obvious. So let me pre-export the scene again. I don't know if I have to do any of this other stuff, but I'll do it anyway. The wall, I told the wall material that it should be brick. I can change it to whatever. We'll see the custom options in a second. Did I miss something? Did I forget my pre-export? Frequency dependent, then I'll change it to, I'll add these things. It could also be so low on these speakers that it's not obvious that it's happening. That's possible. I can always make it louder if I need to. Also, brick will muffle it really hard. So this is an opportunity to play with custom sound parameters. So if you go to custom, you can change more sound parameters, like which frequencies are absorbed and reflected. If I make it not absorb at all, but I make transmission very high, what do you expect would happen?
Would it just be the same as if it wasn't there?
Yes, that's what would happen. Hit all these buttons. So if transmission's at max, then it doesn't matter because the sound will always transmit all the way. Does that make sense? So brick actually does muffle it, but you can't tell because these speakers are so bad. I was testing it earlier. Brick, if we go to brick, oh, we can't do that anymore. Oh, we can. No, okay. If you hit the material and then go to custom, you can see what its parameters were. So brick has very low transmission. So these speakers are so low and bad quality that you can't hear it. But if you have really good headphones, I was testing this before with the Bayer Dynamics, you can hear some of the muffling, even with brick. So that's what materials do. What else do I have to test? Oh yeah, reflections. So let's say that, okay, what will happen if I turn absorption all the way and transmission to 0?
You won't hear it.
That's true. I won't hear anything if I'm behind the wall. So I'm gonna make this, actually brick was already pretty good. I'll use brick. If I make a wall back here, oh, well, I missed. If I put a wall back here and I'm here, I should still hear the reflections from the back wall if reflections are modeled. Does that make sense? We talked about early reflections and late reflections. This would be a sort of early reflection. In order to get it to do that, I need to also tell the audio source to model indirect reflections. Make sense? And I can make them binaural, so the reflections will, they'll be spatialized as well. So I can do this. I turned absorption all the way up, so I can barely hear anything. But even though the sound is occluded, I can still hear it bouncing on the wall because I can see that little sliver of the other wall. Does that make sense? And it will sound much louder when I'm close. And if I go behind this wall, it'll do the same thing basically. So, super muffled. I hear reflections, then I hear the direct audio as well. So, does that all make sense to everybody? Sound good? For assignment 8, you'll basically be playing around with this. You'll be playing around with reverb parameters and things like that. I think it'll be relatively fun, hopefully. Another question, okay, let's say that I do this. Let's say that I make this back wall very small like this, and maybe like, I don't know, let's just say I angle it a little bit like this. Whoopsie. Local. Okay. Where's my user? Oh, there they are. I'm on the wrong wall, but whatever. So if I see this surface from this angle, what do you think, how do you think the sound will change? If it will change. What kind of effect do you think that it has doing this? Any hypotheses before we test it out? You'll still hear that. That's true. And also because it's a very small surface, it will almost sound as if that surface is the source, because it almost acts like a point source. He wasn't very happy about that. So if I play it, oh my god. I just straight up died. Okay, so same thing will more or less happen. I can hear the source, and if I go over here, oh, it's really quiet. You can hear it, it's just very, very quiet. I wanted to make it very, very loud. This is going to sound awful. It's still very quiet. I can't make these speakers any louder, but the point is that you can hear the reflections off of this surface. And if you had good headphones, it would sound as if that were the source itself. Makes sense? You can play with this yourself. If I go to my example environment quickly that I made before, I'll save this as that. Scenes. I made this sample environment before. What do you think that this will sound like? This kind of brick broom, basically.
Not echoes?
Yes, it'll be super reverberant. So it'll muffle a lot from here. Here I'll hear more reflections. The source is inside in the middle of the room. If I walk over here, I'll still hear it be occluded. This is brick, so it's super occluding, but if I go inside, it'll echo a lot and be really, really loud. So that's kind of the point of these libraries. They can reflect reverb, which you can't do by default with a game engine. You can't really model the rays themselves that well. You can use reverb volumes and filters, but it will never sound that accurate. We saw filters last time. They're just like rectangular prisms that have parameters for occlusion, things like that. But the problem is that if you use a bunch of volumes, there will be some discontinuity when you move from one volume to the other. And that becomes really obvious when, well, games don't usually do spatial audio that well anyway, but if you were to do that, it would be really obvious. It's harder to do that in Unity because I don't think its reverb volumes are that easy to use. Do you remember if their reverb volumes are okay? I don't think their reverb volumes are super robust. But if you were to do it in Unreal, it would be really obvious that there's like a discontinuity. And we saw that example, those of you who were in class last time, of being indoors and outdoors. There were those filters that you switch between. There was like a blue surface and a yellow surface. When you walked into the yellow surface, it just suddenly changed. Like there's not much interpolation between reverb zones. So this is how you work with this. Any questions before I show you how to do it on Unreal? Yes?
Is there any way, like in either engine, to create that kind of interpolation? Like if you're leaving a zone, to have it interpolate into the next zone? Without like just modeling it?
I don't think so. I don't know of any methods that can do that. Because reverb zones can change sizes really wildly. And another thing is, say that you have like, say that you are trying to model a really detailed scene and you have like this, or something like that.
Mm-hmm.
Like if you had a bunch of overlapping reverb zones or something like that, it would become harder and harder to model it accurately, even with interpolation. Because at some point, if you move like from here to here or something like that, there will be a really weird discontinuity, even with interpolation, because you can only interpolate with so many different reverb zones at once. So it's just very hard to do that. I mean, you're welcome to test it, but reverb zones tend to not interpolate very well. Like if you move from like an opera hall to a closet, it's just a sudden jump. But reverb rays can model that pretty well. So in Unreal, the method is pretty much the same, honestly, even at a high level. So in this case, I had this cube that has an audio source. In Unreal, at least in more recent versions of Unreal, the plugins for Oculus Audio and Resonance and Steam are already in the engine. You just kind of enable them. For the audio source, in Unreal, the spatialization parameters are inside of this attenuation settings object, which has information for, the occlusion, the spatialization, the reverb, and so on. The reason that Unreal in particular models these differently is because I don't know if you remember, but I said that the ray tracing of reverb actually doesn't work on Android, for example. So Unreal split these up so that if you wanted to use a different API for a specific part of the audio, you can, which is kind of nifty, I guess. That's why they did this. And if you click these, you'll see that they have basically the same parameters, so HRTF bilinear. If you go into occlusion, you see that it's the same. Before we were using raycast, but partial is almost like the sound can die as it goes through a surface. Like the ray gets weaker and weaker. But the parameters themselves are more or less the same, even for reverb and so on. This is just simulation quality. And the same is true for surfaces. You just kind of add. In Unreal, it's called Phonon because it was made in Unreal first, I believe. Back when SteamAudio wasn't SteamAudio, it was just some company. So you still have a geometry and a material component, and they have pretty much the same parameters. And the only thing that changes really is that you don't have to add a listener to the camera. Unreal assumes that any camera can be a listener, but I think the reason that Unity requires you to add the script is because in Unity they try to only have one listener per scene. Like they try to make it, like it'll throw some kind of warning if you have multiple listeners. So yeah, and to do the export scene, it's up here in Unreal. It's up here where the geometry settings and things like that are, and there's still the same options. So add the surfaces that are reflective, export it, and so on. So normally you just have to export scene, and it just kind of sounds the same. The top cube is the reverberant one, and this is a super reverberant room, and when I leave, it'll get occluding. Right now I'm really far from it, but if I'm kind of right on the other side of the wall, like you can hear it. I used brick or something like that, so it's super muffled, but yeah. It works more or less the same way. And the convenient thing about being able to use multiple plugins at once in Unreal is that I can also show you what the Oculus settings look like. So the Phonon material is SteamAudio, but if I were to add Oculus material, you can see that they have more detailed materials by far, but that also makes them harder to tweak. because there is so many different absorption frequencies and things like that. So if you understand audio really well, Oculus Audio is probably a better option just because it has so much detail. But if you don't understand audio that well and you just kind of want to achieve an effect, SteamAudio is sufficient. They're both pretty good APIs, and Oculus Audio also has a ton of different materials that are just built in. So you can use whichever one you want for assignment 8. I think both of them are relatively easy to use. So any questions about this part? No? Cool. Then I'll quit this. Something that was cool, I can't do it here because I don't have the Quest, but this scene did work with the Quest, and what you can do is you can throw the cube that has an audio source around, and you can throw it outside the room, you could throw it all the way down, and it'll actually model correctly. So you can kind of throw the cube into a different room, and that room will become reverberant. So these ray tracing libraries are really powerful. They make really great dynamic audio. So hopefully it's a useful skill to have if you want to work in VR. Audio is becoming more and more important.